So hello, couple words about myself. My name is Dolganov Sergey. I'm working at Evil Martians. I'm an open source enthusiast, and I like to party hard, that you heard, and I like to play drums twice as hard. And actually, the talk that I'm giving supposed to be a full-time talk, but I have only Lightning, so let's try to squeeze it up. Sagas, Wizards, and Ruby. So first of all, my project at Evil Martians called eBay Mug, or eBay for sellers. It's a wizard application. That means that it tries to help a seller through several steps to get some result. For example, I work with logistics, and that means that if seller receives thousands of orders, I try to register them in different logistics systems, and finally seller will be able to just give some papers with the product and for the courier, and that's it. The actual product will start shipping to the client. That's nice, but let's try to understand how it works. Inside we have tools that called pipeline. So for each parcel we have several operations. For example, validation, transportation cost, print label, and stuff like that. And it's just an example of some controller action. Nothing fancy, but actually inside we have some dirty business, because actually each of those actions mutates some external system. It could be UPS system or Russian post, and if something fails, we are unable to roll back it, because when we have a single database, everything is okay. We just wrap it in a transaction and everything will be all right at the end of transaction. But we have separate databases, no access to the external system, how to behave. We need a transaction without transaction. So actually, there is a pattern called business transaction or saga, which helps us to actually conquer this issue. But let's dive into the idea. It's pretty simple that each interaction with the external system we wrap inside a command. Command, as you remember, is just a pattern where you define, for example, up and down methods. If you think about Rails migration, I could use the naming call and undo. It doesn't matter. Then we chain those commands, and at the end of the chain, we expect the successful result. But if something fails inside the chain, we should roll back those commands in the reverse order. And finally, we'll end up with the good state. So in our case, for example, validate request goes to the external system, everything is okay, we move to the print label, it's okay, and then print label fails. And at this point, we have to roll back all the transaction, because we want the our state be in sync with the external, so the best way is to roll back both our database and external one. And the actual logic about this behavior should be put inside the Saga orchestrator. And as an input, we receive a parcel, and as an output, we receive a parcel, but changed in one of two states. The first will contain all the necessary information, or otherwise it will be a parcel in its initial state. So actually, I could stop here, but I've tried to implement it. How do you feel in how many months it took to implement? 3 months. 6 months. It's closer, actually 6 months, and then 3 more to extract it to a library that I will share with you. So what's wrong in real world? In real world, we should actually think about consequences in different problematic situation, like random orchestrator runtime error. Or imagine that you have a chain and it runs, and then our application shuts down. Actually, it happened several times to me, and actually I rewrote these implementations several times to conquer all those issues, like another pipeline that runs in parallel and mess up the state of the original one. Damn. So let me save you several months of your work and share with you how actually the implementation should work in Ruby. So remember the parcel pipeline, it looks like that. We have a class on which we call the chain methods, and then initialize it with the subject. For our case, subject is a parcel, and some additional information that is provided for our case, and then we call it. And you could see that at the end, we will receive a status object that finally helps us to reduce number of conditions, because status just will hold all the information about how to output error or successful state. So, how it works in real world. The pipeline is a sandbox, and when it receives a subject, we immediately lock the subject by a pipeline. And only then we start to execute the chain. Since we locked the subject, that means that we will not have any parallel execution of the same pipeline for the same subject. Then you can see here an interesting point, events. I don't want to talk about event sourcing right now, but the idea here is that event is just something immutable that you store somewhere and you could access it later. And for our case, we have two types of events. First is action attempt. This is an event that we create before any communication to the external system, and we will use it as a breadcrumb in case when the application shut down or something goes wrong, we exactly know what action we attempted to take. Then we run the chain as our documentation said about the saga. And finally, you can see that we have a done event that just contains the information about status of the pipeline chain. Then we start processing events. This is an interesting point because we have a handler only for done event, and inside the handler we will read all the action attempt events and run on them interesting method called applied. What is this? If our chain was successful, why shouldn't we just stop and return the successful result? That's it. Because actually, I face the issue that some enterprise application could return 200 OK despite of any status of real change. That means that even validation failed, I received 200 OK. That's it. So after the pipeline chain, I have to validate that actually my change was applied to the external system. This is why I call the applied method on each action. And again, we have a chain of action. And if all chain was successful, we unlock subject only at that moment. And since that moment, we are able to return the result. And the result would be persistent in both states, in the internal and in the external one. So let's take a look at more complicated case. What if some action fails? So at this point, of course, we do not run the chain to the end. We just create a done event with the status failure. And finally, processing another strategy. It looks familiar, but the only difference is that when we read the action attempt event, we just reverse them. And as you remember, we should run the undo method. And we try to accomplish it. And if our undo chain was successful, that means that we are ready to unlock the subject. But the return value would be failure status. But the parcel or your subject will be in initial state. And this state will be synchronized again, internally and externally. And the final thing, what if our undo chain fail? So at this moment, actually, we cannot continue our processing, and we should not unlock our subject, because we don't know how to deal with the mess state. And at this point, is the only thing actually that you have to implement yourself is just the strategy how you deal with the manual log behavior. For example, in eBay mock, we just do several retries and then put them to morgue, where we just manually try to figure out what was wrong. But most of the cases, retries helps, and that's it. So solution from eBay mock looks like that. We have 6 abstractions there, and actually the whole code that I share with you takes less than 200 lines of code. And prepare your brain, because here we'll go too much code, and don't stick with it because I will share it on the last slide with a link. So just listen and try to get the basic idea, and that's it. So again, the slide with the pipeline, we saw that we have a chain, but we didn't saw what is get transportation cost or register or stuff like that. Inside is the action about your business domain. For example, get transportation cost has an alias for subject to call it parcel, and then a couple strange methods that validate with a bank, validate response with a bank, success with a capital S. Doesn't matter because actually it's some kind of syntactic sugar that we use to exit immediately from the method. But the idea here is that we have to implement only 3 methods, as I said: call, undo, and apply it for a particular action. Then let's take a look at actual pipeline code inside the library. And it's quite simple. It contains the call method that, you remember, locks the subject with the pipeline, then goes through steps. And if any of action failure, we just break the steps. You know, everything is simple here. But interesting moment you could see later that we publish an event that was generated from self. Self for now is the pipeline. That means that inside we should generate a done event. That's it. And then we process done event by a clean class, and finally merge the status. Interesting point about merging status means that actually we have a status about original action call, and then we have a status about the validation or undo. They could have different statuses, and we have to return something. So we should return success only if both were success. So this is the merge. And inside we also will see the context of both checks. We need that because, for example, we could see one failure in the original chain, another failure in the undo chain, and we will merge our errors, and we will be able to see what happened in which chain. That's it. This is some technical stuff for chaining. You could see it in the library. What about locks? Actually, a locking mechanism is up to you because it depends on the transportation, and you could implement it yourself, just interface. What is the action? Again, interface with 3 methods, as I told you. But interesting point here is that when we inherit it, we prepend a wrapped class model. Wrapped call model. And the wrapped call model is just something that publish an event before any action runs in the call method. And again, when we see the events generate method, self is now action, and we could understand that we should produce an action attempted event that will contain all the context. So finally, events, as you might notice, is just interface that says how to work with events. You could work with events without actually event sourcing. You could use some Rails model or stuff like that, and it will work the same way. And finally, clean method is clean class is pretty simple thing, receives an event, then tries to use the success status and use the particular strategy, whether it's validate or undo. Again, simple when you know spend 6 months on it. And final thing is the cherry on the cake is the status. Status is just class that wraps the payload and the marker. Was it failure or success? And of course, success will not contain any errors, and failure will contain some errors maybe. So this is the way how we won the consistency battle. But actually, there are a lot of problems in the distributed systems, and if you face with some of them, I will be ready to discuss them with you, and maybe we find a solution. So thanks. Please watch at our blog, because soon I will announce the real library. For now, I share the code that was extracted from the eBay Mac project, so you could play with it. And a bit later, we'll announce the library. So thank you. Hope it was interesting.
Thank you. We actually have a couple minutes for a couple questions. Any more? People just want to have a lunch, I guess, right? Okay, thank you again.